How to access our website. Go to any browser and type search creators. Click on the first link. Now you have entered our home page where 50k plus study materials are available along with 1000 plus project ideas. We have 10 plus expert members in our team and we also support 50 plus engineering domains. In navigation bar, select University study materials. There are three streams available: computer science, information science, and artificial intelligence and data science. For now, we will click on computer science. Now we will be able to access all the study materials of different subjects of different semesters.
Hello everyone, welcome back to SearchGrid's YouTube channel. Today we are going to look at the further topics in the module 1 of cloud computing. Now today's topic is software environments for distributed systems and clouds. This section explores the software environments used in distributed and cloud computing, focusing on service-oriented architecture, which is SOA, web services, REST, and the evolving relationship between grids and clouds. What it means that this section of software environment is used in distributed and cloud computing, focusing on service oriented architecture. Like it is more focusing on service oriented architecture, web services, REST means representational state transfer. It's a software architecture style for building web services and APIs, and it was created to help. It was created to help manage communication on the internet and the evolving relationship between grid and clouds. Like this section focus main on service oriented architecture. Next we look at the service oriented architecture in distributed system. Entities in a service oriented architecture. Grids, webs, like grids and webs are present. These are the entities which provide the services. Java provide Java objects. Corba, like Corba gives distributed objects. Corba gives distributed object. What is Corba? Corba is a common object request broker architecture. It is a software component which works across different networks and computers. Like it is a software component, like standard software component to work together across networks and computers. And like it's an industry standard that is used for distributed programming, distributed object programming. This is all about Cobra. It gives distributed objects. Next is SOA builds on OSI networking model using middleware like .NET, Apache Axis, and Java Virtual Machine. The software, like the service-oriented architecture, builds on the OSI networking model. What is an OSI networking model? OSI is a Open System Interconnect model. It's a conceptual framework that divides network communication functions into 7 layers. Like it divides the model, like this model divides the network layer, like application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Like it is divided into different layers. The OSI network model divides it into different layers. Using middleware like .NET, Apache, Axis, and Java Virtual Machine. High-level environments handle the entity interfaces and inter-entity communication, rebuilding the OSI layer at the software level. Next, we are going to look at layered architecture for web services and grids. Application-specific grids, like in this diagram, we can observe the layered architecture for web services and grids. This diagram is very important. Entity interfaces include web services description language, which is WSDL, Java methods, and Corba IDL. We talked about Corba in the previous concept. Next is communication systems. SOAP, web services, RMI Java, IIOP Cobra. These are the different communication systems used. And middleware support is WebSphere MQ, Java Message Service, which is JMS for messaging, fault tolerance, and security. Service discovery models. In this JNDI Java, UDDI, LDAP, EBXML, Corba trading services. These are the service discovery models used. Management services like Corba Lifecycle, Enterprise Java, Beans, Genie Lifetime Model, and Web Service Frameworks. Next, we are going to look at web services and REST architecture. What and all the different aspects present in them. In web services, SOAP based. What is SOAP based? So based in the sense based on interaction between three like components, a service provider, a service requester, and an optional service registry. Like it is a service architecture. Based on this architecture, web services, and we'll look at the different aspects in the web services. Fully specific service behavior and environment uses SOAP messages for universal distributed OS functionality. Implementation challenges due to complexity. In REST, representational state transfer focuses on simplicity and lightweight communication. Uses XML over HTTP for rapid technology environments, suitable for modern web applications. Next, we are going to look at evolution of SOA. SOA enables integration across grids, clouds, interclouds, and IoT, Internet of Things. Sensors collect raw data which is processed through compute, filter, and discovery clouds. Filter clouds eliminate unnecessary data to refine the information for decision making. Portals, example for example like OG, FCE, or Hub Zero serve as access point for the users. Next, this is a diagram. This diagram represents the evolution of SOA grids of clouds and grids, where SS refers to sensor service and FS to a filter or transforming service. Like you can go through this diagram to know about the evolution of SOA. Next is grids versus clouds. Grid computing uses static resources allocated in advance, focuses on distributed computing with a defined structure, wherein cloud computing uses elastic resources that scale dynamically, supports virtualization and autonomic computing. Like these are the major differences between grid and cloud computing. Next is hybrid approach. Grid can Grid can be built out of multiple clouds for better resource allocation. Models include cloud of clouds, grid of clouds, and interclouds. Workflow coordination in distributed systems. Now we are going to look at it. Technologies like BPEL Web Services, Pegasus, Taverna, Kepler, Trident, and Shift help manage distributed services. These are the different technologies which help to manage distributed services. Next, we are going to look at trends towards distributed operating system. Distributed operating system, which is DOS. Distributed systems have multiple system images due to independent OS on each node. A distributed OS enhances resource sharing and fast communication using message passing and RPCs. It improves performance, efficiency, and flexibility of distributed application. What the distributed operating system that it does, that it improves the performance, efficiency and flexibility of distributed application. The distributed OS enhances resource sharing and fast communication. What it does, it enhances the resource sharing and fast communication. Distributed system have multiple system images due to independent OS on each node. Next, we are going to look at one table like feature comparison of three distributed operating systems. This table represents the features comparison of three distributed operating systems. You can go through this table it is in the understandable manner only. Next is approaches to distributed resource management. Tenenbaum's classification. According to Tenenbaum's classification, network OS built over multiple heterogeneous OS platforms offers lowest transparency, mainly used for file sharing. Like it is built over multiple heterogeneous operating system platforms which offer lowest transparency, mainly used for file sharing. Like it only provides lowest transparency, mainly used for file sharing. Middleware based OS provides limited resource sharing. Example, Mo6 or OS for clusters. Like middleware based OS provides limited resource sharing only. Truly distributed OS provides higher transparency and better resource management. Next, we are going to look at comparison of distributed OS. Amoeba versus DCE. Amoeba, which is Amoeba, Netherlands. Amoeba is a distributed operating system primarily known for its microkernel architecture. And DCE, Open Software Foundation. DCE is an integrated set of services and tools which are used for building and running distributed applications or research prototypes. Like Amoeba, Netherlands and DCE Open Software Services are research prototypes. No commercial OS has succeeded in following these systems. Future trend focus on web-based operating system for virtualization and lightweight microkernel designs. Next, we are going to look at Mo6.2 for Linux clusters. Mo6.2 is a distributed OS with virtualization layer for Linux. Like it is a distributed operating system with a virtualization layer for Linux. Like it has the virtualization layer for Linux. Provides single system image, supports sequential and parallel application. It provides only single system image. It supports both sequential and parallel applications. Enables resource migration across Linux nodes in clusters and grids. Like it enables the migration of different resources across Linux nodes in clusters and grids. Used in Linux clusters, GPU clusters, grid computing and cloud environments. Like it is used in Linux clusters, GPU clusters, grid computing and cloud environments. Next is transparency in programming environments. Computing infrastructure is divided into 4 levels: user data, application, operating system, hardware. User data separated from application. Application runs on multiple OSs. Operating system provides standard interfaces. Hardware standardized across different OSs. Future cloud computing will allow users to switch OS and applications easily. Like it is a prediction like future cloud computing will allow users to switch operating system and application very easily. Like it will be more easy for the users to switch between different OSs. Next is parallel and distributed programming models. In this diagram, you can observe a transparent computing environment that separates the user data, application, OS and hardware in time and space An ideal model for cloud computing. If they ask any question on parallel and distributed programming models, you should write this diagram. Afterwards, you can write your theory. By this, the chances of getting more mark is increased. Next, in this table, parallel and distributed programming models and tool sets. We can observe them like model like MPI, MapReduce, Hadoop, description about them and different features present in them. You can go through this table. Next is message passing interface, which is MPI, a standard library for parallel programming in C and Fortran. Like it is a standard library for parallel programming in C and Fortran. It is used in clusters, grid systems, and P2P networks. Like where it is used? It used in clusters, grid systems, and P2P networks. Alternative parallel virtual machine, which is PVM. Next, MapReduce. Scalable data processing model for large clusters like Google. Like MapReduce is scalable data processing model for large clusters. Uses map like key value generation and reduced merging values function. Handles terabytes of data across thousands of machines. Like it has the capacity to handle thousands of machines across like data terabytes of data across thousands of machines. Next is Hadoop. Open source version of MapReduce initially developed by Yahoo enables massive data processing over distributed storage and provides high parallelism, reliability and scalability. Next we are going to look at one table. In this table, grid standards and toolkits for scientific and engineering applications are there, like standards, service functionality, key features and security infrastructure. You can go through this table like it is in understandable manner only. Next is Open Grid Services Architecture, which is OGSA, a standard for grid computing, supports distributed execution, security policies, and trust management. Genesis 2 is an OGSA based implementation. Like a standard, it is a standard for grid computing. It supports distributed execution, security policies, and trust management. Like the Genesis 2 is an OGSA based implementation. Like Genesis 2 is a like a map grid into local file system, like what I can say, like Genesis 2, the way it is designed, it is based on OGSA based implementation only. Like it is like Genesis 2 is made out of OGSA based implementation. Next is Globus toolkits, middleware for resource allocation, security and authentication in grid computing, developed by Argonne National Lab and USC. IBM extended Globus for business applications. Like IBM extended Globus for business applications also. Next we are going to look at performance, security and energy efficiency of cloud computing. Performance metrics and scalable analysis.